Okay, so in the last class, we started talking about networking and how it's very important for enterprise operations. We found out what a network is. We found out that we have private and public networks, all right? And then you also have your LAN and your WAN. That's your local area network and your wide area network. We found out what makes up these networks. And then we talked about network devices. We talked about IP addresses, private IP and public IP, how to recognize a private IP, it always starts with either 172, 192, or 10. And then the public IP starts with any other number apart from those three sets, right? We also talked about IPv4, the types of IPs, IPv4 and IPv6, how mostly is IPv4 being in use, but all well, all current network devices or all current devices that can connect to a network support both. We saw how the IPv4 network looks like and also how the IPv6 network looks like. Now, we talked about the subnetting, CIDRO notation, subnet mask, and we talked about different devices that makes up the network. Now, before we go on, someone has left the classroom. Favor was here before; she's no more here. All right. So, before we go on, I'm sure we all know what each of these devices do. Now, I said they can be in hardware format or in software. So you can have softwares that does the function of a router or a hardware router. So let's not get confused, all right? I tried to show us pictures of each of these devices. Some of them look alike anyway, but from the ports at the back, you get to know what they are for. All right. Before we go on, I would like us to do a network diagram. All right. So a network diagram is a diagram that gives the blueprint of a network. So any network engineer or any network administrator can pick that blueprint and implement his network. All right. Now we have a role in cybersecurity called security architecture. If you are doing security architecture, you will be involved in, designing the security of an organization. Now, part of that design would include the network design, the network diagram, and then you're also designing it with security in mind. All right, so we have various kinds of or various ways of depicting a network with and then other ways of improving security on it. Now they might call you in like, okay, we have this network already in place. They give you the blueprint and say, oh, what can we do to improve the security? So you are supposed to improve that design. All right. So for this, there's actually an app called Lucid Chats, right? It used to be free, but right now they make it only free for I think 2 diagrams. All right. So I can't use this right now, but it's very good for network design, right? It's not need for network anyway. Mostly IT kinds of designs, database designs and all that. It's very good for them. But I can't use this right now. So I found out another tool, not as good as this Lucid Chat, but it's manageable. And that is forgotten the name, something paradigm, visual paradigm, yeah. So I'll just it's online, it's based online, so it's not an app you can, download or use. You use it the way it is online. But you can download your diagrams when you're done. All right, so let me just log in. I logged in my Google account. Yeah, so it's somehow like Canva, like you can use it for, it's a design tool, but what I'm more interested in is for the network diagram. Sorry, I have something that always disturbs me here. Okay, so if I go to artifacts and diagram, so I can create a new diagram here, let's give it a name. Let's just call it tribe up, yeah. So I'm doing a network diagram here. So you don't need to name it. It's a network diagram I'm supposed to look for. So it's going to prepare my canvas for me, and then I start using it. All right, so this is my canvas, and then these are the tools I can use. All right, so for this, I would want to draw my network diagram. Please bear with me. I just started using this app a few days ago, so I'm still getting to know my way around it. So let's start with, I always like starting with my switch because that's where you have a lot of devices connected to. So this should be a sign of switch. Yeah, this is my switch. In network, in networking, there are symbols for different devices. All right. You see this something that looks like a star here. It's normally the symbol for a switch. Okay. So I have my switch. Let me just put a couple of systems. Okay, let me put a PC here.
Hello,
And
sir.
then
Hello, sir.
I can put another PC here.
Hello. Can you hear me, sir?
Yes, I can hear you.
Yeah, sir. Please, I didn't really get the definition of switch, hub, router, and those things that you mentioned.
You didn't get it in the last class, and you did not ask. Okay. So yes, so your
So your mic has muted. Oh, I can't hear you. Hello, sir. Your mic is muted. Hello, can you hear me? Ugochukwu, can you hear me?
I can hear you.
Okay.
I can hear you. Yes.
Okay, that means it's his own
sorry,
mic.
sorry, sorry, sorry about that. The call came in. Yeah, you were saying something.
Okay, so I wanted to tell you that we can't hear you.
Yeah, sorry. A call actually came in to stop my network. Um, so let's quickly run this over. All right. So we have network devices, right? In your network, there are some devices that make the connections possible. All right. So we have a router, we have a switch. Now, for you to know what a router is what connects different networks. All right. So if you have a LAN network and you want to connect to the internet that's outside the LAN network, you will need a router. To connect between one LAN and another LAN, you will need a router for it. All right. So a router connects different networks. If you want to connect between a LAN and a WAN, you will need a router for it. Now, a switch connects devices within the same network. So within a LAN network, all the devices within that network, the switch that connects them. The other day I was using this as an example here. Okay, this is actually a network diagram. You can see this is a switch. I don't know why it's called a router. This is a switch, but it's doing the work of a switch. All right, you see that all these devices are on this network and they're all connected to the switch. So you can't just, for example, you want to get a file from this system, right? This system can't just connect directly. It must pass through the switch. So to send the message to the switch recognize where that message is going to and then move it there. And then if this guy wants to reply, he sends the reply back to the switch. The switch recognize where the message is going to and move it there. So that's what the switch does. But your router is connecting these network devices outside to another network. All right, that's for router and switch. For firewall, is it just router and switch? You say you don't understand?
No, sir, including firewall.
Okay, your firewall is a security device, so it's something that is monitoring traffic. So any traffic coming into your network or going out of your network is being monitored by your firewall. And then you set rules. The firewall works with rules. You are the one that will set the rule. So you let the firewall know which traffic you want it should allow in and which one it should stop. And it follows that rule. So your firewall is like your security man at your gates. All right. For so firewall, which other device do we have? For hub, we no more use hub. Hub used to does the same thing with the switch. The only difference is that your hub is not secure. So it broadcasts all this message. Your switch is only working with sending messages between two devices or between maybe the router and a device. But if you put a hub here, the hub will broadcast that message to all the devices connected on that network so they can each have access to it. All right. There may be some situations where you want to use a hub, but it's not really advisable because it's a security flaw. Okay. So for your modem, you need a modem to connect to your internet service provider. It's what converts digital data into analog and then analog back to digital because your telecoms service is on a different kind of network from your normal system, your digital systems. All right. So for your computer to be able to connect to the internet through maybe MTN service or whatever, you need a modem for that. So modem is just short for modulator demodulator. So it converts digital traffic to analog and then analog back to digital. All right, so that both kinds of network can interact with each other. Okay, that's what the modem does. So without the modem, you can't connect really to the internet. So your modem is normally giving you connection to your internet service provider. All right, wireless access points there are devices that helps wireless device connect to a wired network. So if you look at this network, for example, here, it's a wired network, but your mobile phone and tablet will not have a network cable connection. All right, so you would have to have a wireless access point connected to this network that it can now transmit and connect, maybe like the way you have hotspots or Wi-Fi connections. All right, so that will connect it to this network. So that's what your wireless access device does. Now, remember your network connection could be physical, like using cables, or it could be wireless. All right. I'm sure in your house, connecting to SpectraNet or whatever network you're using, you use wireless connection. Even your smart TVs use wireless, although most of them have network ports where you can use network cable to connect it. All right. So, Emmanuel, is that okay?
Yes, sir. Thank you, sir.
All right. So let's go back to the diagram we were doing. To understand a network like this, you can use something like like a school. Let's use something like a school. So if you have a school, of course, within a class, you have a classroom as a LAN, right? And then each student has his own student ID. All right. That ID is the IP address. Now, for you to interact with each student, you will need to, take permission from maybe your class teacher or whatever within that same class. Now, that is your switch. All right. Now, for that school to interact with another school, you have to pass through maybe the principal or something to make it possible, right? The school administration. That's your router. So if you are going to another school for a competition or whatever, someone has to plan it, someone has to make it possible. It's your router that will make it possible. Now, your firewall in the school will be your security man at the gates. All right. The security man at the gates gets to determine who can go out of the school and who can come in, giving proper permissions. All right. That's how the network is. Now, your router is also called a gateway. So by the time you look at your, sorry, where's my command prompt? Your router is also called a gateway. So in case you see something like that, let's do ipconfig. Yeah, this is it. Do you see default gateway? This is not my actual, the one I am actually using. It's because of what's the name of this thing? VirtualBox, that all these things are here. But the main one is this one. Yeah. So this is my default gateway. All right. So this is the IP address for my router I'm using to connect to the internet right now. All right. You can see that the IP address is different from the IP address of this system. This is the IP address of this, my laptop. So you can see it's different, but because they are on the same subnet, the first three sets of octets are the same. Remember our subnetting explanation. It's just this last one that changes. All right. Now let me go back to my network diagram. So for the name of this website is called Visual Paradigm. So you can search for it and use it. All right. So I've created my switch, and then I also want to create, let's put one digital device. Let's put a phone or something. Is there a phone here? I'm not seeing any phone. This is normal phone. Not that one. Unless we want to do IP phone. Okay, this is what I'm looking for. All right, so we have this, right? Let's just put it here. Now, let me put this one up here. Now, I can also have a server machine on my LAN. So I want to put a server. This is signed for servers. Server. No, this digital storage. Should I put web server or normal database server? Let's do server and storage. All right. So this is my server, right, with my database storage on it as well. Now, what I want to do now is to link all of them to my switch. So you see this arrow, you can just pull it and it goes there. And I want it to be both ways. So I select the kind of arrow. All right. So we do the same to this one, and I select both ways. We do the same. I move from this one down to my switch as well. All right. And then this one to my switch. I select both ways too. Now, we have these here. Now we want to put of course, we'll need a router Where's the router? It should be a router. No, that's a hub. This is a modem. We'll need a modem. Let's put the modem here first. We need a firewall too. Let's put it here too. This is a sign for firewall. It's normally a wall with fire on it. If it's a colors diagram, the wall will be red. Is it the wall that will be red or the fire that will be red? Something will be red anyway. I'm trying to look for my modem. It looks like this switch, but it's different. Okay, so let's put a printer as well. This is a scanner. You can put a scanner, you can put a printer. Yeah, this is a modem, but it's a wireless one. This is a switch. Where's the wired modem? This is it. Oh, I've put the modem already. Oh, sorry. It's router I'm looking for, not modem. This switch. Where is this router? This modem. I can't seem to find this. Okay, let's do a search with them. All right. So we have a modem here, and I'll put it here. This one is looking better. Is it modem I'm looking for or router? Why do I keep typing modem? Sorry. So let's look for router.
So you changed the switch to modem.
I'll remove it, sorry. So this is sign for router, right? This arrow sign. So I'll just pick one. Which one looks better? This actually is signed for it, yeah. So then pick this one. All right, so I'll just delete one of these. Uh-oh. So this front one I'll delete. All right, so we're good. I'll clear this. All right. I want to also reduce the size of this. It's too big. I don't have space. Okay, so I have my modem here. Sorry, my router here, and then I have my modem here. Now, my switch and my router would have a connection. And then so this is here. My router connects to my modem. That arrow that used to show me to connect double arrow, I'm not seeing it again. And then I need that arrow. I'm not seeing it again. So these arrows are supposed to be pointing both ways, but I can't see it's not showing me again. I don't get it anymore. Well, we'll come back to that. So this is this. Let me put this firewall down here a bit. It's down so that we'll have space up here. Right. And then this now points to let's put this sign for our outside network. So this is our internet. I want to do both arrows here too, but it's giving me only one. Okay, that's giving me two. So let me delete this. So it's giving me only one. And let me copy this then. Let's improvise. Right, and then here too. Why is it picking text? I don't seem to be able to remove this text. So we'll come back to doing that double arrow. Now we can name all these. So if I double click on anyone, I'll just call this internet. I'll call this firewall. Router, modem, PC, PC, phone, or mobile, right? And then this is okay. We can have one more device here. Let's put a copier or a printer. Where is a printer? This is a printer. right? So let's stretch this. Let's move these a bit. Is our directional whatever that is refusing to work. All right. Let's manage it like this. Okay. Now, this is bidirectional, so it's both sides. The arrow goes both ways with this one as well, right? So this is a simple network diagram, and we can see that, okay, there's something else I can do. This printer is too big. Let me reduce the size. The systems as well. Now, this PC can represent multiple systems. It's the same kind of connection, right? So it's not like it's only two PCs in this network. But your modem should, like modem, router, firewall, each one represents one, and switch as well. Mobile too can represent multiple mobile phones. All right. But your server should represent one. So if you have multiple servers, you have to put them up the way they are. Now, what I want to do is use a shape. Where are shapes? These are shapes. All right. So let me wrap this up. I'll just send it to the back. All right. And like this now, my firewall is at the perimeter, right? And so everything in this box is my LAN. So let me just put a text. Here you did enter. Okay. Oh, I just put it up here. So this is my network, right? This is my network. All right, this is my network diagram. It's a simple one. Of course, we'll come back later and put some more security features. We'll come back later and put some more security features here. This. All right. Do we get this? Oh, I didn't name my switch. Okay. Yeah. Any questions? Hello, do we have any question?
No, sir.
Okay.
No, sir.
Now, I sent a message a few hours ago that we should download PF Sense. Have we downloaded it? Have we downloaded PF Sense? Please let's download it right away. I hope we're all with our systems here. The link is on the Discord under the resource channel. So this is the website. So PFSense is a firewall by Netgate. Netgate does network security devices. They have their own firewall, and it comes with PFSense installed in it. So this is actually their firewall machine. Where's I sent the link is on the site, is on the Discord. Can't remember where it was. Okay, so this download here. Yeah, so this is it. You just hit download here. And I think the link I sent is to this page, this particular page. So what you need to do is to select image type here. And please, this is the one to select AMD 64 ISO IPMI/virtual machines, right? We want to install it as a virtual machine. So this is the one I want us to select, please. So once you are done, add to cart. So it's like an online store, but PFSense is free. So you can see it. They are not charging you any money. All right. So if I go to my cart now, all I need to do is to check out. Right. So I'll just check out. I already have this item in the cart, but it's costing $0. Now, here you will have to create an account. You have to create a PFSense account. It's a free account. So I'm signing in right now. Where's my email now? I've not gotten the email. Oh, that's coming. Ah, Okay, so I've signed in. So we have this here. And I will just complete the order. Oh, I didn't accept the terms and conditions. So once you accept it, the download link will show here. Yeah, so that is it. Once I just click on it, it starts downloading. So this is the size, 315 MB. Please, let's download this. Would use it hopefully today. If not today, then in the next class. But before that, this stuff we created, I can save it. How do I save this again? Okay, I can export it. Let's just export it as an image, right? And export. Let's just give it a name. So Fiber network diagram, and then I'll click down device. So that's downloaded it. Let me just put it on the Discord. Hold on, my Discord is loading. So the name of this website is Visual Paradigm. While this is loading, let's continue. Okay. I don't understand what's happening to my Discord though. My system seems to be dragging on. Okay, guys, I've put it on this Zoom chat. You should be able to get it there. Okay, my Discord is up now. Let me close this Google. That's what slows down my system sometimes. All right, I have it on the Discord as well. Okay, let's move on. Now now I want to talk about the OSI model. And OSI means open system interconnection. It's very important in networking. It helps us know or helps us to put a logical interface, not necessarily logical, but it helps us break down our network into various interfaces so that we know at what stage what is happening within at the network. All right. So there are 7 layers. All right. You have them here. You have them here. So for network communication, you have these 7 layers. You have the application layer, presentation, session, transport, network, data link layer, and physical layer. Now, for network traffic to happen, it passes through all these layers, and all these layers represent different levels or different aspects of your network. Now, let's start with it. So for layer 1, we have layer 1 is called the physical layer. There are 7 layers of the OSI, right? Layer 1 is the physical layer, and that's what handles physical connections between devices. Now, example of physical connections are connections like using cables, like your network cables, your connectors, your electric signals. That's what happens in layer 1. So there are physical connectors connecting 2 or multiple devices. Now, for layer 2 is your data link layer. So layer 2 will manage data transfer between the 2 devices. So after connecting using a physical medium, data has to be transferred between those 2 devices. That is where your layer 2 comes in. Hold on, let me. So remember, your switch is connecting devices, but your switch also you are using a network cable to connect data, connect your switch to maybe a system or whatever. But then you're also transferring data between those 2 devices. So that's the layer 1 for connection, then layer 2 for transfer of data. Now, layer 3 is where we call the network layer, and that's what handles routes between different networks. All right. At the network layer, that's where there's packet routing. That's where you start using logical addresses for your IP addresses. That's where you determine where the network or where the network data is going to be transferred to, and then where the path, which path is going to take. All right, because your network traffic moves along various paths. All right, so it's the layer 3 that will let you know that. Now, the layer 4 is the transport layer. All right. Layer 4 now ensures that, that data that we've mapped out the path is going to travel. Layer 4 will now ensure that the data is transferred accurately and reliably. All right. It's layer 4 that will determine whether the data you sent out will be received or not. And then it also verifies if that data is received. So on layer 4, your communication comes into play. That's where you start using TCP and UDP. We'll talk about TCP and UDP later. They are both network protocols, network transport protocols. All right. So for layer 4, you want to the transport protocol would manage host-to-host communication. So it's looking at communication between 2 hosts. It will also ensure data integrity. So make sure that data is not lost or tampered with. And then it also does some level of error correction. So if data is not accurately transferred, therefore we kind of rectify that. All right. For the fifth layer, that's your session layer. It manages sessions between applications. So the session layer manages sections or connections between applications. So like between computers, it helps in handling setups, coordination, helps with termination. The session layer is where you start looking at things like encryption. All right. So that's your session layer. Now the session layer is not encryption. Sorry. I've mixed it up. It's the presentation layer that does the encryption. All right. Not the session layer. So for layer 6, that's your presentation layer. It translates data into a format the application layer can use. Now, the last layer is the application layer. Layer 6 is what prepares your data for the application layer to understand. So it formats that data that you've received or the recipient has received, and then encrypts it. And also it can also compress that data to ensure that it is readable by the application layer. Now, at the application layer, which is layer 7, that is where the data is now interfacing with either the user or the application software. So when you are browsing, for example, you open a website, you click on a link, data has been sent out to the server, wherever that document is. For example, this download now. And then the server will fetch it and download it and then open a new page for you. So that's where you are receiving. So your presentation, your application layer most times could be your browser. It could be a graphical user interface as well. All right. So it's what is closest to the user, and it also helps to make possible interaction with software applications. All right. So your browser could use your application layer, and then it uses certain formats as well. So your browser uses HTTP, for example. You have FTP, file transfer protocol. We'll talk about these things. Let's not worry too much. In the next few slides, we'll be talking about our various protocols. All right. So the OSI layer is very, very important in networking. It's something you need to understand and you need to know very well. All right. For those of us that will be writing professional exams, getting to networking and network security, questions always come out on your OSI layer. So you should understand at each stage what is involved. Also, if you are doing forensic analysis from the OSI layer, or you are doing incident response from the OSI layer, you can know where issues are coming from and know which area to go and fix it. All right. Now, moving on, Wireshark. I think I have a missing slide. Did I delete a slide by mistake? Okay. So talking about Wireshark is actually a tool, right? It's a networking tool that you can use to analyze network traffic. You can also use it during investigations. You can also use it to check for or to fix, to check where issues are. So for troubleshooting, you can use it to fix it. You can also use it for identifying security threats. All right. So it's a tool that network security professionals use to analyze your network traffic. And your network traffic, we call it packets. So your network traffic is captured in packets, and then Wireshark can help you analyze those packets for certain anomalies and then also to troubleshoot your network. Now, Wireshark is a free software, yeah, and you can install it on Windows or Linux or any operating system, and then start using it immediately. All right. Okay, I think this slide is supposed to come before this one. Okay. Yes. So it's organized now. All right. So Wireshark, we can download and install it on any machine, but it comes prepackaged on Kali. So let me open my virtual box. I will look at Wireshark briefly. In short, before this thing opens, let me close all these things. All right. All right, so let me use Kali. Which Kali am I using? Let me use this one. So which one? Which one? I think is this one. Let me just increase the memory. So 2 gig. All right. So but before we even go on to Wireshark, I want us to draw a network diagram on our own, right? Am I having to virtual box open? I want us to draw a network diagram on our own, right? Then we'll move on from there. I want us to draw a network diagram on our own, and don't copy what I did, right? Use visual paradigm, and you just create an account and log in. But what I want to do, let's put us in breakout rooms. We have 15 minutes for this, so you have to work fast. So we're working in teams, in 2 teams. Yeah, 2 people each. So what I would do, hope we're together. Can you hear me?
Yes, sir.
Okay, because I noticed we don't really do activities during these class sessions, and it's like some of us are not, we're not practicing on our own, just up to the class and listen, and that's all. So I want us to do a network diagram because network architecture is actually very, very important. And since I've done a basic one, of course, we can do our own basic ones. You can mess with the networking tools or the network diagrams. Is it diagram they call it now? The networking devices on the left-hand side of the visual paradigm, but create your own network diagram, and let's see. So let me put us in breakout rooms, and I'll be going in to each of the breakout rooms. We are 4 here, so Just give me a little second. Seconds. Let me put us in the breakout rooms. So what you can do, one person can, log into Visual Paradigm. You can use your Google account, just so that you don't need to start registering and all that. So I'm going to put Emmanuel and Favor. No, I'm going to put Emmanuel and Oluebube in the same room, then Favor and Ugochukwu in the same room, right? And then I will be going from, I'll be going into each room. So just once you see the message to join your room, just click on it and join the room, please. So we have 15 minutes. Let's assume it's 9:15. By 9:30, we'll come back. But I'll be moving in through both rooms and, giving my own tips on what needs to be done. Then you can always ask your
Hello,
questions
sir.
there as well. So,
Hello, sir.
yeah.
Sir,
Yeah, I
what's
can hear you.
the name of the website we are supposed to create
Visual
the
Paradigm.
network diagram?
Visual Paradigm.
The one
This is it.
the one I'm seeing on Google is like an AI,
It's like what?
like an AI model. It's telling me to download this software.
Okay, I didn't even know they have a software. I've not really checked on that. If there's a software, you can download it, but honestly, I've not checked on it, so I can't really tell what you see when you download it. But I'm expecting it should be like the same canvas. Let me just start the download and see. Oh, free trial. Okay, I don't do free trials. I only do full free. I'll suggest we use the online tool. I'll suggest use the online tool because this one will require some level of registration, and then you can use it for 30 days. Someone has left. That's Bright.
So I'm still here. I had to log in with my laptop.
Oh, okay. So how do I add to this room now?
So where's the option for the online version of it?
Just hit login, right? And then you can create an account with Google. Do you understand? Just click this link and wait, I need to start this thing all over again. Okay. Because Emmanuel left, he vanished. Okay, so I've added Emmanuel back. All right. See you in your rooms. Okay, the rooms are open now. Just click to join the room. Hello, guys. Please join your rooms. Emmanuel, Favor, Ugochukwu, join your breakout room. Hello. Emmanuel, join the breakout room, please. Ugochukwu. Is there any reason why you guys are not joining the breakout room? Emmanuel, can you hear me? Hello, Emmanuel. Hi.
Hello, sir. Hello, sir. Hello, sir. Please, sir, add me to the breakout room.
I've added you already.
I don't know. When I tried to join, I went out or something like that. Maybe network. Can you add me back?
Okay, hold on. You can join in now.
Hello, sir. Can you hear me? Excuse me, sir.
Sorry, just a few seconds. I'm rounding up with the other team. Just give me a few seconds.
Okay, sir.
All right. Sorry, Favor, you were saying something.
Yes, sir. So you said that you mentioned that you dropped the one that you created.
I've
You
lost your
dropped it
audio. I can't hear you
in
anymore.
chat box. Hello. Can you hear me
Okay,
now?
I can hear you now. I can hear you now. Yeah.
Okay, you mentioned that the one you created earlier, you dropped it in the chat box. I can't find it.
Hello,
Okay, I've
Favor,
seen
can
it
you?
now. Sorry. Thank you.
All right. Okay. So I don't know. I've relayed the message that you guys should work in your 2 month team and then get the network diagram available for me. All right. I'm also dropping the link here. So we have that there. Now let's see. Okay, so back to Kali.
Recording in progress. Recording in progress. Recording in progress.
All right. So this is Kali. I'll just go to the start menu, and then what you want to do is to type Wireshark. All right. So this is Wireshark.
So you're not sharing
Okay.
your screen.
Oh, sorry. I've forgotten to share my screen. All right. So what you missed is that I opened Kali. So on the start menu, you can just search here for Wireshark and then click on it. All right. So it opened this application for me. Hold on, my screen is so okay. So this is Wireshark. I'll just expand this. All right. Now, let's pick up some network data. Um, so I can use this one I'm using Kali. Let's use this, and this is to start capturing packets. But let me first open my browser. Why is Firefox taking long to open? All right, let me start capturing. So here, this is to start capturing. So this starts capturing your network packets, right? From your network connection. So I'll just hit it and it has started capturing, right? So let me come back to my browser here and I can just go to any website. Let's use Curate. And then let me use another website. Let's use Wikipedia. Okay, this is the link to Wikipedia here. Oh, sorry, it's QurateHQ. So it's still capturing data at the background. You can see it here. And we have this open. All right. Why is Curate taking so long to open? All right. So we have these here, and I can stop capturing. So to stop, we use this, right? So I'll just stop it. And that stopped. It has stopped capturing. Why is it still capturing data? It has actually stopped, but the last set it captured is going to scroll through it. All right. I'll come back to this. Okay, so we can actually close this. All right. So we have just those the two actions we did just now. We have this whole network capture that it did, right? Something we can look at here is let me expand it a bit. Yeah, something we can look at here is that your packets are the data it captured, they are being stabilized, right? And then you have different columns. So the time it was captured, the source. So the source is the IP address where that data is coming from. And then the destination is the IP address where the data is going to. All right. Now remember that when you are browsing on the internet or you're browsing a website, what you are doing is just download and upload. All right. You are getting data from the server or the website where the traffic is, and then it's that's so you're sending the request, and then the server is also replying. So it's both ways. So there's a source, there's a destination, there's another source, there's another destination. So you can see that in this first stage, this was the source sending to this destination. Maybe there was a reply from this source now to this destination. You can see that they are the same. So they're interacting with each other. All right. I know this is my IP. This should be my IP because it's a private IP. And this should be another IP, maybe that of Curate or Wikipedia because it's a public IP address. Now, if you look very well, remember I told you that you need to recognize an IP address type just by looking at it. All right. So which kind of IP? Is this IPv4 or IPv6? I've already showed us private and public. Is this IPv4 or IPv6? This particular one.
IPv4.
Yeah. So it's an IPv4 address. Now here too, you get to see protocols. All right. There are different network protocols. Because we are using internet traffic, you see a lot of TCP and TLS. All right. But there are also other protocols that can be used. All right. Because it was a website we access, it was websites. You see that the protocols are practically the same. All right. Now, if you look at here, info, you have detailed info about the kind of traffic. All right. Ports are shown here as well. So port 443. We'll talk about ports very soon. I think in the next one or two slides. Okay, we'll talk about ports soon, Sha. Yeah, protocols. Yeah. Okay, we'll talk about ports under network security. But when you look at it, you get to see which port, like this 443 is actually a port. It's actually HTTPS. So I know that this is using encryption, all right? And then you have this as well. ARC, SYN, and PSH and what have you. I'll explain what some of these are, and then we'll get to understand. Now, if you click on any of these data here, you will see it's more described here. All right, so down here is broken down into the encoded format. Sometimes you might see it encrypted. All right. Sometimes it might be in encryption if you use 443, like something like this. And then you can get more information about the data here. Okay. Now you see source ports, destination ports, and then some other information that you want to look at. It is using transmission control protocol. The internet protocol version and what have you. You have the destination IP, the source IP, different, more information. So you can always look at any of these. Sometimes this may be encrypted, so you may not be able to make heads and tails of it, but at least you get to see the data. Now, Wireshark also has a query language. All right. So there's a way you can filter data. So for example, let's say I want only data related to this IP address 151.101.193.91. Now you can check here, right? And then let me move this down so that it's actually disturbing. Okay, you can check here and then see the IPs, the setting filter languages here, right? You can also add and remove from here. You can add and remove. So the ones that you use often, you can leave it here or remove them. So for example, now if I want to maybe I want to search for only one or to search for data that is relating to an IP address, I can do something like this. IP dot addr, and then I do equals, and then the IP address I want. So let's say I want only data that has to do with this IP. Let's say 34.107.221.82. Oh, sorry, my number is not on. 34.107.221.82, and then I hit enter. They put I here. Okay, so that's it. And then I hit enter, and it will filter the traffic and give me only traffic that is showing this. So you can see that either the source the source IP or the destination IP is this particular IP address. All right, so it has limited the results to just this, right? That's limited it to just this, right? And then because I searched only 2 websites, so it would be hard to filter it in a way that it would be very little results. So that's one way of doing your filter. You can filter by anything. So you can do let's say IPv4 or let's say IPv6, and then if I hit enter, it will give me only IPv6 addresses. So only information with IPv6 addresses. This one is far more limited. Remember I told you that you will hardly see IPv6 interactions on the internet because most people are using IPv4. Most websites use IPv4, and most networks, go with IPv4. But then some might just use IPv6. All right, so you see this filter working. There are so many of them. There's actually a query language for Wireshark, so it's something you can learn. All right. but it comes with some form of help. And then you can use the help option here, right? The query options here. There's a section where it even has a more detailed list of what you can do, or you can learn the query language and use. All right. You can limit also by ports. All right. You can limit by ports. I think that one, I may not have forgotten that query, but I think it's tcp.ports and then equals, then we select a port to use that you want it to limit your or filter your listening to. So let's try port 443. And all your results would have port 443 there. All right. If, for example, you might be wondering why Wireshark. I'm going to come back to Wireshark. I'm going to get some malicious network packets, so we would analyze it. I think I have one, but I don't really know where it is right now. The way it works is assuming one of these IPs is malicious and you're able to recognize that, oh, this particular IP address has carried out some malicious activities on my system, but I don't know what's carried out. So let me check that network packet for the time where it was active and see what actually the perpetrator did or the hacker did or whoever. All right, so you can use IP to search, same way I did just now. IP dot address ADDRO, and then use, this is not dots. If you are typing and it shows red, that means that your query is not correct or it's not yet complete. All right. Once it shows green, yes, it's complete. You can use that query. So equals to this is my own IP 10.0.2.15. All right. So you can limit it to only that result, but this result will be a very long one because it's my own private IP. All right. Now, what you want to do is you want to look at what this IP address did, the activities of this IP address. Now, there is what we call three-way handshake when it comes to networking. It helps you know if a network connection is successful or not. All right. So the three-way handshake is that one party wants to communicate with another party. It may be two devices. The first one will send a message called a SYN, SYN. All right. Once it sends it, the receiving party would send back a message called SYN ACK. All right. So like I acknowledge the SYN you sent. I think SYN, SYN, SYN means synchronize or something like that. ACK means acknowledge. So SYN ACK means I've acknowledged your synchronization. And then when the first party receives it, he will now send ACK, that is acknowledged. So once you see ACK, just ACK, it means that connection is successful, and then there's been transfer of the data can now be transferred between the two parties. So for example, this ACK means this connection is successful. So if you go through, you'll be seeing things like SYN ACK, and then just ACK. Let me scroll down, see if we'll see another one. Yeah, you can see SYN here, right? So this is the first leg of the connection. So you have three ways: SYN ACK, and ACK. That's why it's called a three-way handshake. All right. So that's it. Another thing you want to see in this info, you see that there are some places where there's application data. So this IP actually interacted with a web application and then got data out of it. All right. So you want to check whether it's something that is in order or not. All right. So we'll come back to Wireshark especially when we are doing our penetration testing. But I would also get network packets that we can use for investigation. But this is just our normal browsing data. There's nothing wrong with this. So you can come in here and open a network packet with this. All right. So you see the analyze place as well. You can display filters here. So these are the filters that are available right now, right? And then you can add to it. You can create your own custom filter, like write your own query and add to it, or remove from it. All right. Just cancel this. So that's Wireshark. It's a very big thing in networking. There are people that their job um, in organizations is just to use Wireshark to analyze network traffic. All right, especially when there are incidences, they analyze the traffic to know what the issue is. They also help to fix problems in network connections and network related issues as well, using Wireshark to do investigation or troubleshooting. All right. So, okay, so let's talk about network topology. Now, for you to do a proper network architecture, you have to, or network design, you have to understand different network topologies. Now, some of them are just, yeah, they are outdated, right? But it's good that we know them. Some have, they all have certain advantages and disadvantages. So let's look at the various network topologies. So your network topology is the way devices are connected to each other within your network. Now, remember the diagram we did just now? I actually used the network topology for it. All right. This network diagram we did, this one, a network topology was used for it. All right. It's actually the star topology, but by the time we get there, you understand it immediately. So now, and you need your network topology to dictate how data will move within your network. All right. And if you don't get it right at the beginning, it could cause a lot of bottlenecks, a lot of issues within your network. It could even make costs go up or go down. Now, when you are selecting a network topology, there are different things you need to look at. You need to look at first of all, scalability. Scalability is very important. So scalability is how you can increase the size of your network or reduce the size of your network without it having any adverse effects. All right. So when you are doing topology, you should look at scalability. All right. Because sometimes there are some topologies that work very well in small settings, like maybe you have just 10 devices. But by the time you scale up to like 2,000 devices, that topology will crash. All right. Reliability too also falls at where if there's an issue with one device within a network, does it affect other devices or not? So your topology will determine that as well. All right. So let's go straight into the types of network topologies. You have your star topology where all the devices are connected to a central hub. All right. Remember, I said this diagram will use star topology. You can see that all the devices are connected to your switch. That's the central location. And then you have everything going directly to the switch. Your router, your systems, your mobile phone, your, what's it called? Server, right? Everything passes through the switch. So all network data will pass through the switch. All right. Now, the advantage of this is that it's very easy to manage. It's very, very easy to manage. All right. because you have a switch there that is doing the work for you. All right. It's also scalable, so I can add one more device here and just connect to the switch, and automatically my network still continues working. I can reduce the devices without having any adverse effect. All right. Now, if there's failure, maybe one system, goes bad, or there's some issues, it doesn't affect the whole network because you can just pull the system out and everything is still working fine. All right. Now, the disadvantage, if your switch should fail, your whole network is down. Now, imagine this scenario where this switch goes bad. Nothing can work well again because all data passes through this switch, both ways. All right. So your switch is a device that needs to be protected. It must not have any hardware fault or any issue. All right. If an attacker should come in now and take over your switch or pull down your switch, that's a denial of service attack already, because your whole system is down. All right. So that's the disadvantage of it. But for us to know, your star topology is the most used topology right now in the world. Like, it's the most reliable. So most organizations, they use star topology. All right. The next one is the bus topology. That's the one where devices share a common backbone or a common network, right? It's called a bus anyway, a common bus. So the way seats are in a bus and then there's a central aisle, that's how it works. So each device is connected to the medium here, like that, and then the traffic flows up and down this way. All right. Now, what's the advantage? This one is easy to install and you require less cable. For your switch, you might require some cables because all these connections, you use network cables to make them happen. All right. Back to our diagram. All these connections is network cables actually that is running, right? Network cables are not so expensive, but of course, by the time you use a lot of it, it becomes something that is a bit pricey. All right. Have we all seen a network cable before? Have we all seen a network cable before?
Yes, sir.
Guys,
So
why
I've
don't
seen,
you answer questions on time? What's happening? It's either yes or no now.
No, sir.
so I've seen cables, but I don't know if it's network cable.
Okay, I'm showing us a diagram of a network cable now. This is it actually. This is it. I'm sure we've all seen it. Maybe we don't know what it was as at when we saw it. So if you are using a computer, you will see a port on your system where this stuff can enter, right? Both sides of a network cable is like this, right? And then you connect one to one device and the other one to the other device you are connecting it to, that you want to establish connection with. All right. In offices, of course, you can't have all the devices in the same room. So you may have to have a connector on the wall that, runs the cable to your uh, server room, and then it comes out there and enters your switch. Then your system will just plug into that connector on the wall. The connector is somehow like a socket, but it's just this end that goes into it. All right. So this is your network cable. And if you saw at the back of our firewall, switch, router, and the rest, you see that there are ports where these cables go into. All right. So let's move on. So the bus topology, of course, requires less cable, but the disadvantage of it is that if there's an issue similar to the star topology, if there's an issue with the backbone here, everything goes down, right? Any issue that happens in the central area, the whole network is affected. Okay, now the next one we have is the ring topology. All right, this one, all the devices are connected to each other in a circle. All right. So data travels in is it clockwise? So that data travels in one direction. You get to choose the direction anyway, whether you want it to go clockwise or anti-clockwise. All right. So data travels in one direction. Now, if the data is traveling clockwise, that's like this. If this guy wants to get information from this, he can't go direct to this. He has to first pass through here, and pass through here. All right. Before he gets the information, so I'll now pass it to him. Now okay, so that's how it works. Now you can see that it's already seriously flawed. All right. Now the flaw is that if one of these devices go bad, the whole system is down. It's not like the bus topology or the star topology where if one device goes bad, everything is still functioning fine. All right. The ring topology, any issue with one device affects the whole system. The system goes down. Now, any form of intrusion or cyber attack on one system also affects all the systems because data is going around through all of them. Now, if I take control of this system, I can follow the data map and then take control of all the other ones as well. All right. The advantage is that the data travels quicker anyway, but it's not, security-wise, it's very, very poor. All right. Now, the next one is the mesh topology. This one is actually the most reliable and the most secure or redundant. Redundant in the sense that each machine is connected to all the other machines. All right. So this machine is connected to each of these machines, so they can interact with anyone he wants to interact directly, and vice versa. There's no middle switch or anything. There's no middleman. All right. It's very reliable, and but the disadvantage too is that it's very expensive because all these are data cables. Imagine connecting to all these devices. Now imagine if you now have 3,000 devices in this network. First of all, the network administrator is in short, he will go crazy, right? So it's very complex over time. It's not really scalable. Scalability will bring complexity. That's one of the disadvantages. Another thing too is expensive, right? Getting all these connections available cost money. By the time you scale up again, the connections increase by far. All right. So the mesh topology is not so okay because of that. But in terms of connectivity, it's the best. Now, I told you that the star topology is mostly being used. So most times in your network diagrams, you see that people are using star topology. But that does not mean they don't use others. It's just that the star topology is like an industry standard right now. All right. So what do you need to consider when choosing the right topology? Of course, you need to look at how scalable it is. If you're adding devices, everybody wants to grow, right? If your business is growing, your connected devices is growing as well. So you want to look at how scalable is it. So by the time you're adding devices, will your topology still stand? You want to look at the performance as well. If there's issues with your network, or with a particular device, how does it affect the whole network? Will it pull down the whole network, or can you still survive? Now you also look at cost and reliability as well. All right. Cost in the sense that, of course, cost is a big deal in all organizations. If you are not able to reduce costs or to bring in income, then don't increase cost. All right. So what is the cost of implementing the particular network topology that you want to use? All right. What's the cost implication on the organization? It's what will determine whether it will go ahead, you will go ahead to use it or not. All right. Now, just to remind us of common network attacks. Of course, these are general attacks that not only affect networks, affect so many other things, applications, and the rest. To remind us of our introductory class to cybersecurity fundamentals. Malwares can affect networks. You can use phishing attacks over networks as well. There could be denial of service attack. Just a quick one that we said here. You can see that, okay, I've said it already, that our, why is it saying 100? Star topology, if the switch gets compromised, then the whole system is compromised, right? Sorry. So yeah, if the switch gets compromised, then the whole network is compromised. So you have to deploy tools to make sure that your network does not get any form of incident. All right. All right. So let's go back to what we're doing. So denial of service attacks can happen as well by either bringing down one critical system within your organization to stop that to stop operations. You can also use network traffic as a means of denial of service in the sense that an attacker will just flood your network with useless traffic, a large amount of useless traffic, and then make the network crash, and then your actual users will not be able to access it. All right. Also, attackers also try to get unauthorized access through your networks. And then you also have insider threats as part of a common network attack. So of course, your employees within your organization, they pose their own threats as well. All right. We have different network protocols. All right. A protocol is actually a rule that defines what a network communication should look like. All right. There are different network protocols, right? We have TCP, we have UDP, and all that. But would so on the internet, we have TCP. That's a network protocol there. That's the transmission control protocol, and it's mainly used on the internet. And then it's you can break it down into there are some other protocols that make up the TCP. So we have things like HTTP, that's the hypertext transfer protocol. That's the one your websites use, your browser use to communicate with your websites. We have HTTPS, that's just encrypted HTTP. The S means security there. I call it security, but it means that there is some form of SSL or TLS in place. TLS is the main one used right now. SSL is kind of going outdated, but TLS and SSL means that there's encryption in place on that HTTP traffic. So when you see HTTPS, you know that it's the same HTTP traffic with encryption involved. All right. We also have FTP and FTPS, file transfer protocols. So that's to transfer file across from a device to another, maybe from a server to another device and vice versa. And then, of course, the same way we have with HTTP and HTTPS, FTP has FTPS, which is secure file transfer protocol. All right. There are others. We've talked about SSH, that's secure shell. for remote connection. We have RODP. That one is only for Windows, to remote desktop to connect with Windows. There are a whole lot of them, right? We have DNS, domain name server or domain name service. I think domain name service. So your DNS is what maps your IP address with your URL. So the URL will work with which is called like when you know you want to go to google.com. Normally the system, the internet does not see it as google.com. It has a particular IP. You are going to the IP address of that website. But because we are humans, you can't store IP addresses in your head. Imagine you want to go to google.com and then you have to type 42.38.192.51. And then each website like that, you have to remember it is hard. So they came up with a DNS service where you can map it to. All right. So it converts IP addresses to URL names. There's a table that does that. It matches it and then gives you that. All right. So there are so many other protocols. There are the ones for there's one for emails, SMTP and the POP, and even IMAP, IMAP. There are so many other of them with specific uses. All right. Now, apart from TCP, we also have UDP. UDP is Unified Datagram Protocol. And UDP, what UDP does is it helps for things like streaming, both podcasts, all those audio streaming and video streaming, for gaming as well. All these live broadcasts. All right. The main difference between UDP and TCP is that TCP verifies data that it has been successfully sent and successfully received. All right. UDP does not. So that's why, but UDP is faster. All right. It doesn't verify anything. If you lost data, you've lost that data. TCP, if there's data lost, it will go and, recover it and, make sure it's put back together at the destination end completely. But UDP does not. That's why when you are like watching a video online or something, a live video, you see the buffers. And then the parts that buffers, you miss that part, it moves on. All right. So that's why UDP is like that. But UDP is faster. It's a faster protocol. There are other protocols as well. You have ICMP and what have you. But as you are going on, you get to see them and use them. All right. So I've talked about most of these protocols. Yeah, TCP/IP. Okay, I thought someone was mentioning something. So I've talked about most of these protocols. Yeah, and even some more. All right. Now, let's talk about network security. And when talking about network security, you notice that we've been talking about network. But how are we going to secure a network, right? There are different ways of securing a network. The very first way you want to secure a network is using a firewall, all right? When it comes to firewalls, the first way you want to secure any network, all right? So like I said earlier, a firewall is a tool or a network security device that that monitors incoming and outgoing traffic and then set rules on which one it should allow or deny. All right. But you get to set the rules. So it follows the rules that you set, you've given it. All right. So when it comes to network security, there are devices, there are tools that you use for network security. Firewall is one of them, antivirus, IPS and IDS. So IPS is intrusion prevention system. IDS is intrusion detection system. All right. You can also use a load balancer as well to help for security. All right. So at this stage, I would like us to install our pfSense. How many of us are on our systems right now? How many of us are on our systems? So
I'm not.
guys, try and be on your system while we're having this class so that you can go along with the demos on your own as well. I already have pfSense installed here. Let me do a new one. So to install pfSense, I'll just go to new. We'll give the virtual machine a name. So let's call it pfSense firewall, right? Because I think I already have that name. So what I would do, I would just add something to it. But on your own, you can just call it pfSense firewall. Okay, don't have that, but let's just add something to it just to be on the safe side. Where's my underscore? Let's call it driver. I already have 2 firewalls here that I use. So now the ISO image will be the image we downloaded. So I have mine somewhere. Oops, I don't know where it is. Okay, I have it somewhere here. So I'll click order. Okay, this is where I downloaded mine. So after downloading it, you need to extract it. So this is mine. And now for the OS edition, use BSD, right? This is a bit different, right? So BSD, to select free BSD, every other thing is fine. Now, if you go to hardware, pfSense doesn't use much, just 1 gig RAM is fine, right? And then let's see the hard disk. The hard disk to 16 gig is fine. It doesn't use much. So you can even use 10 gig. But let's leave it at 16 gig. All right, so I'm not changing anything here. I just wanted to show us here. Okay. So I will just hit finish. All right, now please listen up. Before you install pfSense, you have to set your network. All right, so if I go to network here, now remember your firewall, you need to set a LAN and a WAN. All right, so let's use it on VirtualBox. So you need 2 networks. So you need normally your firewall will have minimum of 2, and there's a LAN and a WAN port. So I'm going to set a second adapter here. All right, enable this, and then what we want to do is we want to make it an internal network. So this will be our LAN. Remember, your LAN is an internal network. So I'll do internal network. By default, it takes this internet. You can give it any name you like. And then let me just make sure the MAC address is different. So let me refresh it. All right. So having done this, it's okay. So now you can see that you have 2 networks here. This is your WAN. So this is what will connect you to the internet. Why this is your LAN. All right, this is your private network. This is your public, not public, WAN network and LAN network. All right. If you look at any other virtual machine, the operating systems or whatever, you see there is only one network adapter there. But for your firewall, you have to have 2. All right. So you will set one as a LAN and one as a WAN. If you don't do this, your network, your firewall will not be properly installed, and you may not be able to configure it. All right. So when you are done, you hit start. Oh, before you even hit start, sorry, there's something I needed to have done. I will need to stop this. Just close it. So before we start the firewall running, we need to set some or all some of our machines to be on the LAN network. Remember from our diagram, did I close that diagram again? Remember from our diagram, we had a LAN network and then we connected machines on it, right? So let's connect some of our virtual machines on our LAN network. Of course, automatically your firewall will be on the LAN as well. And then PFSense will create your router, your switch and everything for you. So we'll do this. I've already set my Ubuntu on internal network. So normally yours here, you just change it to internal network and make sure it is internet that is there or whatever name that it is you gave your internal network. All right. So you do the same for, I normally clone my Ubuntu. So I have two Ubuntu. So I did for both of them for Windows 10 and one of my Kali. I can't remember which one. Okay, so it's the second one. Where is the second Kali? I have more than one Kali. Okay, so this Kali, you can see it is on internal network, internet. All right. So any machine you put on this your internal network is part of your LAN. The ones you don't put on internal network, they are not part of your network at all. So they are seen as an outside machine. All right. So let's now start our firewall. So I'll start this. All right. So it's going to boot. Just give it a few seconds. We'll just wait for it to. Sorry, guys. Give me a minute, please. All right, sorry. Okay, so this is the first place. Hit accept here. Your mouse will not work here, so only keyboard and arrow keys. So accept. What's blue is actually what's selected. So we're going to hit OK on install pfSense. So we're going to set up our network now. All right, so hit enter. Now you can see because we set up two devices, two network adapters. You can see them here, both of them, EM0 and EM1. You can see they are both active. So we just hit OK. Everything is fine. All right. At this place, we'll proceed with installation. Hit OK. All right, so it's asking which should be our LAN interface. So we'll go down to EM1, which is this our internal network, right? And it starts counting from 0 and 1, right? So this is our internal network, EM1. Hit enter. And then it's asking, so this is if you want to change anything about the network, this is where you want to come to. All right, so you can change the IP address and subnets here. It's using subnet 24, right? And then for the DHCP means Dynamic Host Configuration Protocol. So it automatically assigns IP addresses. All right. So using subnet 24 will give you 256 or 100 IP address. Let's check the what's it called, the graph we used the other day. So I'll just expand this. So for 24, we have 256 IP addresses here. So that's the IP address that is available. And then the DHCP automatically sets to start from 100. So any device that will be put on this machine will start from 100 and end in 19. All right, so it's going to use about just 100 IP addresses. You can change any of these if you want, right? Sorry. You can change any of these, but I'm going to leave it the way it is, right? So let's proceed with installation. During the configuration, you can also change you might decide not to use DHCP. You might decide to use static IP addresses where you are the one that will manually be assigning IPs. But with this set, any new device you add on your machine, it automatically gives it an IP. All right. And then you can change this too, right? If you are using this in an enterprise, of course, you already have your IP address settings and everything you are doing. So you would want to change it. But the way it is now is fine. So proceed with installation. What's happening? Is it hanging? Okay, so LAN is EM1 and then 1 is EM0. So everything is fine. So we'll continue. Hit enter to continue. Now this is where PFSense changed over the years. Before it does the whole installation does it offline, but now it now connects to the Netgate web server and start downloading and installing certain things. So we'll wait for it to complete. All right, so it has not yet even started the installation. Okay. It's saying I don't have an active subscription. No, I'm not subscribing or anything. We'll just do install C. All right, hit enter and continue proceed with installation. Everything about the file system is okay. You don't need to set anything here. Now here it's asking us to select which virtual device configuration type. This is the default. This is fine. And you hit enter. And then here, the disk that you want to install PFSense to, this is our virtual hard disk, 16 gig virtual box hard disk. And then hit enter again. Are you sure you want to format your virtual hard disk and installed? So this is fine. Yes. Now, which version do you want to install of PFSense? Will you install the most recent version, the current stable version? Hit enter. And this is where it starts installing and downloading and loading. And it may take about 5 minutes. So let's wait for it. We're almost done. Oh, this thing is not stuck here. It's been on 7 for a while now. All right. All right, so it's done. I'll just hit enter. Okay. So it's asking if I would like to reboot. I'll hit enter to reboot. Then up here, just go to devices, optical drives, and remove. I didn't remove that thing on time. So let me restart it. Let me close this and run it again. So it was trying to read the disk again. And I'd already removed it. So let me just start the PFCS again. Now make sure that here is empty, right? Then start. So the first boot is going to do some, it's going to take a bit longer than normal. Right? It's going to do some configuration. All right. So this is our first firewall boot. Just a quick one. You have our WAN IP, which is this, and then our LAN IP address, which is this, right? And then the V6 version of our WAN is here, the IPv6 version. We'll be working with the IPv4 anyway. So this is the pfSense terminal, but we will not use here. We would open one of our machines that is on our LAN, and then go to the browser and go to this IP address. There's a web interface for it, a GUI interface that is more friendly than what we have here. So that's what we'll be using to work with our firewall. But you can set some configuration here, but you can also do it on the GUI interface. All right. So normally you need to leave this running and then open another machine and access your firewall there. All right. Another machine on your LAN. The machine must be on your LAN network. Then you access your firewall there. So we'll do that in the next class. So before our next class, which is on Saturday, is let's download and install pfSense. So we'll just start with the web interface and then configure it and start using it. All right. So we'll stop here today, and let's please remember our network diagram as well. Do we have any question? If your pfSense is properly installed, when you get here, you'll see your WAN IP and your LAN IP. All right. Remember to set the network properly here, and then put some of your virtual machines on the LAN. You can always clone your virtual machines, but when you clone, remember to reset the what's it called? The MAC address. All right. Any questions before we go? Just close this.
No.
Any questions?
I have a question, sir.
Yeah, go ahead.
While installing the full operating system as
Can you speak louder? I can't hear you very well.
when you were installing, can you hear me now?
Yes, I can.
When you were installing the pfSense, you chose the operating system as BSD. I wanted to know what the BSD there meant.
It's a kind of file system. It's somehow like Linux, but it's different. Just hold on. Close my pfSense. Close my. So pfSense works with the BSD file system, right? It's not really a file system. It's like an operating system. Yeah, not a file system. So we have it here. So this is it here, right? It's like an operating system, but it's based on Linux. It's Linux based, but it's lightweight, very small. And then it's not all kinds of it's not, there are some standalone, mostly free applications that run on the BSD operating system. So if you look down here, you see that these are different operating systems: Microsoft, Windows, Linux, Solaris, BSD, IBM. This is Mac. All right. So pfSense works on FreeBSD, right?
And
So these
another
are
question,
different types of BSD. Yeah.
can this pfSense machine be used as
You say you have
an
another question.
yes? Can you hear me?
Yeah, I'm listening.
Can this firewall now, this pfSense firewall, be used as an actual firewall? Since we installed it here on a virtual machine, can we install it on an actual system and then link it to our existing network?
I lost you briefly, so I don't fully understand what you asked. Can you repeat it?
Am I clear now?
Yes.
This PFSense virtual that we installed on the virtual machine, can we install it on an actual system that's not a virtual machine and use
Yes.
it as a firewall for our existing network?
Yes. Actually, pfSense is a very popular firewall. They even have the hardware, like they have the hardware firewall, like the device, and then this software comes with it. It's very popular. You can install it. You can even install it on like Windows Server now. You can install it on your Windows Server operating system and use it on your network. So why I decided for us to do it separate is because we are running a security outfit, right? A cybersecurity outfit. You want your security devices to be on their standalone systems. All right. So that's why I prefer my firewall to be on standalone, but it's still part of this network. So we are actually going to simulate a network that all these our machines are on the same network with our firewall, and then we'll protect the machines using the firewall on that network. So that's what we're going to do in our next class. That's why I put all of them on the same LAN. Do you get? So pfSense is not, if you look at the installation, where was it? If you look at the installation, you will see that I told us to select the one for virtual machine, but there are other types of installations as well. There is a software installation as well that you can use. But some are not free, right? For this free one, you can get free one for virtual machines for USB sticks. All right, so you can only install pfSense on a USB and just attach it to a system. But that USB, you can't use it for any other thing again. Like the software is installed directly on the USB, so it's like the way you use USB, what they call that thing for Windows, to recover Windows. You know, anything you install on it is permanent. You don't put any other thing attached to it. So that's it. You can read more about pfSense. It's a very popular firewall. It's a very popular firewall, and a lot of organizations use it. There are a whole lot of firewalls anyway, so it's not like it's only pfSense you get to, see. Windows has its own firewall, but I prefer for us to use pfSense because the Windows firewall is pretty basic, very, very basic. So I want us to use something that is more industry standard. Linux has its own too, called UFW, uncomplicated firewall. It's still basic, and it's the name is just uncomplicated. It's a bit complicated because it works on the terminal. Like you use the terminal to do your firewall rules and settings. So that's it. So the company that does pfSense is Netgate. They're a popular firewall, network security company. So they have their own firewall, and then pfSense is the software they put with it. All right. Any other question? Any other question?
No, I got that.
All right. All right, guys. So see you on Saturday. Please, let's remember our projects for the operating systems. All right. Good night, everyone.
Good night, sir.
Night, sir.
Sorry, before we go,
Attendance.
attendance. Sorry, before we go, just give me a few seconds. Let me take attendance. What's the name of this application again? I forgot, sniping. Actually, no, no. Please, hold on. I don't know what's happening. All right. Thank you. I've taken the attendance. Thank you.
Right, sir.
Yeah, good night.